Hi everyone, this is Suyan with Falcon and Swift Geomatics. Today, I wanted to share some of the data products that Falcon and Swift creates from drone imagery. My goal is to show you how these data products lead to improved vegetation inventories in the context of seismic line restoration. In general, our data-driven approach provides three main advantages to seismic line restoration planning. Advantage number one is that we can identify and therefore protect areas of natural regeneration. And advantage number two is that our detailed inventories allow us to create precision prescriptions. Finally, advantage three is that our drone-based approaches have low barriers to entry, so there's high potential for capacity building and community engagement. In this video today, I'll be focusing on our workflows for getting to advantage number one, mapping and protecting natural regeneration. For this demonstration, I'll be showing you data products for a sample area. And with that, let's begin our data tour here in QGIS. Right now, you're looking at an in-situ oil sands area in Boreal, Alberta, which is within one of the caribou habitat ranges. The lines shown here are candidate seismic lines for treatment. So this area already has a high-level treatment plan developed under the Caribou Habitat Recovery Program. And you can see that here that the blue lines are designated for treatment, the pink is advanced regeneration, and the yellow color represents project exclusions. For the sample area, there's about 30 kilometers designated for treatment. Right now, this background imagery is just from Google Satellite, but we've also collected drone data for parts of the sample region as well. So now let's zoom in and take a look. Here's the drone imagery for a sample line designated for treatment, and I'll zoom us in a little bit more. So for those of you who are familiar with drone imagery, this image might already make a lot of sense, but if you're new to looking at drone imagery, let me orient you to a few things. So here's a seismic line that's running through a forested area, and all of these things in the adjacency are trees. So we have conifers. This is a deciduous tree. And because the resolution of this drone imagery is about 1 centimeter, we can see features that are very, very small. For example, here's a little conifer seedling, and we can also see a great amount of detail in the forbs, shrubs in this area. If I move us over here, you'll see a trail running through this seismic line. We can see some coarse woody debris. And here's a ground control point, which is something that we use to georeference our drone imagery. In a seismic line recovery context, everyone is very interested in trees. At Falcon and Swift, we use deep learning models to detect conifer seedlings and trees in an automated way. Our models detect trees and seedlings in these orthomosaics. Our goal is that if you can see a seedling in this image, then our models should be able to see them too. So here we have an area with a lot of seedlings. And now let me turn on our predictions layer to show you what the algorithm has detected. And here you can see all of these circles represent a detected conifer, and it's colored by species. So these red circles are spruce, and this turquoise color is tamarack. And when you get used to looking at this imagery, you'll actually notice that due to differences in branching structure, it's actually quite easy to distinguish spruce, tamarack, and pine in drone imagery. So it's easy to see conifers in drone imagery, and instead of circling them manually, we use deep learning to do it automatically. Here's a short video that shows what that looks like. Here you can see the conifer predictions being made patch by patch, and for this test area, we cover about 18 square kilometers, and this takes us about 5 hours. Okay, so back to our data tour. We have tree and seedling detections, and we want to know their density on seismic lines. Falcon and Swift has tools for delineating seismic lines based on canopy height models, which are spatial rasters that depict the height of vegetation. Here, these polygons shown with black lines are the seismic line footprint. And now I'll zoom us in a little bit here now. When it comes to restoration planning, having a good footprint is essential for many reasons. For example, knowing the width of the line helps us to predict the number of seedlings to purchase for planting, and also to know what size of machinery needs to be sent down a line. For analysis purpose, our footprint here was split into 100-meter segments shown with this thicker black outline, and then we further split these segments into 10-meter square plots shown here in the yellow. So now that we have segments, we can overlay our detections, and then we can use a simple overlay summary to get the number of conifers per subplot. So here you can see that in this subplot, there were 0 conifers detected, and in this subplot, there was 5 conifers detected. We can aggregate this to any scale that we like. So here, we've aggregated those counts to the 100 square meter segment. So this 100 square meter segment has a total of 16 conifers, and we can further aggregate this to the line level. So this line here has a total of 225 conifers. We didn't have drone data for the whole area, but we did have optical data from an airplane that overlapped the 30 kilometers designated for treatment in this area. So we applied our workflow to this data, and here are the results. Here, the lines shown are the ones prescribed for treatment, and the white ones have no conifers, but progressively darker greens mean that the segment has a higher density of conifers. Using this, we found that 20% of the segments have a conifer density greater than 1,000 stems per hectare already. And because these areas have such high pre-existing regeneration, we believe they could be removed from the treatment plan. By doing this, we protect existing regeneration by avoiding unnecessary interventions, and also this means that we can reallocate resources to lines that do need more intensive treatment. This marks the end of our first Falcon and Swift data tour. I hope you enjoyed this video, and thanks for watching.